So now we're going to talk to you about the alcohols and their reactions. So 3 reactions: combustion, elimination and oxidation of primary, secondary and tertiary alcohols. So first of all, combustion. To get combustion reaction going, you obviously need a spark or some sort of ignition. Now alcohols burn like alkanes in oxygen, creating carbon dioxide and water. That's the 2 products. To balance this, first of all, let's balance the carbons. So there's 2 carbons there, and there are 6 hydrogens there, so that's 3 water. There are 4 oxygens there and 3 oxygens there, so that's a total of 7. So 3 O2, not forgetting that oxygen, which I've highlighted in red there. It's often forgotten about. Often burn with a blue flame, nice blue clean flame. A cleaner flame than the alkanes. Okay, now we'll move on to the elimination reactions. I'm going to pick on butan-2-ol, not difficult example, but useful to show you this one. So butan-2-ol, when you eliminate water, so elimination is the removal of water from an alcohol, you get but-1-ene and but-2-ene. So the catalyst, there are a range of catalysts you can use. Aluminium oxide, solid catalyst, sulfuric acid, so that's concentrated sulfuric acid. Concentrated phosphoric acid will also work. Conditions: heat. You need to blast this, you need to break bonds, so heat's required. Now, 2 products we get. First of all, but-1-ene. When we make but-1-ene, we're removing an H and OH on these 2 atoms here. So we form but-1-ene, which will look like this. So I've dehydrated the alcohol, and that's the first product. Now, when we dehydrate in the other position, you see if I take the green there, I'm removing the H and the OH, but in the middle of the molecule I only get two different products. They're both called but-2-ene, however, one will be Z-but-2-ene, and one will be E-but-2-ene. So this here is E-but-2-ene, and this is Z. Z because they're on the same side of the double bond, E because they're on the opposite sides of the double bond. So that's elimination of water from an alcohol, forming an alkene. Then we'll move on to the oxidation of the primary alcohols. We use acidified potassium dichromate, which is toxic. It's a toxic orange chemical used to oxidize an alcohol. You can do a partial oxidation, which forms an aldehyde. The O here just denotes the oxidizing agent. It removes the hydrogen here and the hydrogen there. The hydrogen must be removed from the carbon which is connected to the O. It cannot be a hydrogen connected to a neighbouring carbon. So that will create then our product, which is an aldehyde, ethanol, and water as the byproduct. Conditions: distillation. The second, which is complete oxidation, is where we have an excess of the oxidizing agent. And first of all, we remove the H's to make the aldehyde. Then we form the carboxylic acid. So this is the end product. The carboxylic acid called ethanoic acid. And this is formed under reflux with excess potassium dichromate acting as the oxidizing agent. Just to write the name of this, you have partial oxidation with distillation and less of the potassium dichromate, you form ethanol. When this reaction takes place, you do actually go via ethanol first, and then the ethanoic acid when the complete oxidation occurs. And then look at secondary alcohol oxidation. Here's our secondary alcohol, so that is propan-2-ol. The oxygen here removes the H there and there, so we form a carbon-oxygen double bond in the middle, and that is a ketone. The ketone is called propanone. That's the functional group. And the byproduct is water. So we distill, we still have acidified potassium dichromate. You only get, you can't oxidize this any further. There's not an H here to put the oxygen in. You can't break this carbon-carbon bond to put an oxygen in the middle. So that is the only product of a secondary alcohol oxidation with potassium dichromate. With tertiary alcohols, this is methyl propan-2-ol. You don't get any oxidation at all with potassium dichromate, because although you can remove that hydrogen, there is not another hydrogen attached to this carbon here, and you cannot remove the hydrogen on the neighbouring carbon, hence no oxidation takes place.